What we're going to do in this lesson is we're going to learn how to solve another kind of equation, okay? In this particular lesson, we're going to solve exponential equations, okay? Now you may say, I don't even know what an exponential equation is. In fact, you may also say, I wouldn't be able to tell the difference between an exponential equation or a polynomial equation or a rational equation, okay? Well, I've already said that, pointed out a few times how to tell the difference in these things. Let me show you what an exponential equation is. So you're probably used to seeing, 7x squared. That's a quadratic expression because it's a base of a variable to the power of 2, okay? So let's say, plus 3x minus, 19 equals, 5x plus 1, okay? So it has an equal sign, so it's an equation. It's an equal sign with an expression on both sides. It's an equation. The highest power of x in this whole thing is 2. Therefore, this is a quadratic equation. We solved these, a couple lessons ago, okay? And then we did something very similar. Then we did, let's say we have like negative 2x cubed, plus 7x squared. Now we have the highest power is 3. And when the highest power is 3, 4, 5, whatever, we call it a polynomial equation, generally speaking, or maybe a higher power polynomial equation or a higher degree polynomial equation. Well, exponential equations are very easy to recognize because here's the thing. Do you see how here we have x as the base and the exponent is 3? Well, if we switch that, if we make 3 the base and we make the exponent x, now it's what's called an exponential equation, okay? So an exponential equation is any kind of equation, or let's say exponential expression or term. An exponential term is a term in which the base is a finite number. It's basically a constant, okay? It doesn't have to be a constant. It can include a variable or it can include some other stuff. But generally speaking, we have a base and then the exponent is what is variable, okay? So we have 3 to the power of x. So because x is variable, this could be 3 to the first power, 3 to the second power, 3 to the third, 3 to the 17th power, 3 to the 1 million power. It can even be 0, 3 to the 0 power. It can even be negatives, 3 to the negative 5 power, 3 to the negative 17 power, whatever, okay? So this having a variable in the exponent makes it what we call an exponential term. Well, when we then set it equal to something on the other side, like 5, now it's an equation because it has an expression on both sides, and the variable expression has x in the exponent, and therefore this is an exponential equation. And these are actually very easy to solve. I'm going to show you how to solve them, but they can look intimidating because they don't follow the normal rules of polynomial algebra. And because they don't follow the normal rules of polynomial algebra, sometimes we call them transcendental, meaning they transcend the normal rules of algebra. We need other rules from outside of, well, not outside of algebra, but outside of polynomial algebra. We need to go find rules that are not our usual add, subtract, multiply, divide terms to be able to deal with this equation, okay? Another example, because this exponent can become very complicated. You could have, 7 to the power of 5x squared minus 4x plus 8, okay, equals, 19, okay? And what we have here is now, look, in the exponent, we actually have a quadratic expression. But because it is in the exponent, because there is a variable that is in the exponent, we call it an exponential equation, okay? And this, it's not quite as easy to solve as this, but it follows the exact same procedure. So let's go ahead and jump right in and solve some exponential equations. So what we'll do is I want to build your skill. I want to level you up. I want to train you with a few steps or a few techniques, a few abilities, okay, specific skills. So let's start with the most simple of all exponential equations. Let's say we had something like, let's go back to 3 to the x. Let's say we had 3 to the x is equal to 91, okay? And, this is kind of where you want to be. In fact, I want to tell you that really the first step in solving an exponential equation is making sure that you have only an exponential term on one side of the equation, or on one side of the equal side. So let's say you had like 5 to the 7x plus 1 power minus 3 is equal to 22, okay? So we cannot, what I'm going to show you how to do to solve an exponential equation, it can't be done. We can't really do the main first step unless this is by itself. The problem is we have this minus 3 with it. And this minus 3 is going to cause us problems in trying to do the solution. Now, you can have it there. It's just when you have it there, it's actually just going to make the solution extremely difficult. And so it's just so easy to get rid of it. All we have to do is add 3 here and add 3 here. And now we have 5 to the power of 7x plus 1 is equal to 22 plus 3 is equal to 25. Okay? Now, this is actually even easier to solve. There's a way to solve this that a lot of algebra instructors teach to students, and it's a great method for solution, but we're not going to use that one in this. The reason that this is so easy to solve is we know that 5 to the second power is equal to 25, and so all we'd have to do is set 7x plus 1 equal to 2. But then if we did that, it would take away from the solution method that is supposed to be used when solving something like 3 to the x equals 91, because we have no idea what power would give us 91, so we're going to have to do something a little more complicated, okay? All right, so step 1 is going to be make sure that you have the exponential term, the base with the exponent is the only thing on one side of the equal sign. Once you have that, now what you're going to do is this. You're going to apply a logarithm. We're going to use logarithms. We've seen logarithms just a little bit before, and they're so easy to use. I know they sound intimidating, but it's bad enough when we put letters into math. Now we're putting words into math, but don't worry about that. So here's what we're going to do. To solve this, what we're going to do is we are going to make both sides of the equation be a logarithm. Remember, the rule in algebra is that whatever it is you do to one side of the equation, you have to do the exact same thing to the other side. No changes, nothing. It's got to look exactly the same, the thing you do on the left that you do on the right. So what we're going to do is this, we're going to turn both sides of the equation into logarithms. So we're going to, and the logarithm that we create, so we need a logarithm with a base, and that's not the hardest, but I mean, that's the main decision that has to be made here is, what should the base of the logarithm be? Well, a logarithm is an exponent, so the base of the logarithm is going to be the base of the exponent. So whatever this base is, that is at the base of the variable exponent, that is what your log base is going to be. So we're going to do log base 3. And then inside the logarithm, we're going to put this whole thing. We're going to put 3 to the x power, and then we're going to put equals. And over on the right side, since we did log base 3 of the left, we have to do log base 3 of the right. So now we're going to do log base 3 of 91. And so we've done our first algebraic step. We did it legally, we did it correctly, and now we can proceed with the solution. Okay? Now I want to remind you that when we learned the properties of logarithms, one of the properties that we learned is that inside of a logarithm, if there's an exponent, that exponent can be moved to the front of the logarithm as multiplication. And so that's what we're going to do here. We're going to take that x and we're going to remove it from inside the logarithm. We're going to take it off the 3 and we're going to move it to the front of the logarithm as multiplication. And so we're going to wind up with x times log base 3 of 3 equals, this side's going to stay the same for now. In fact, it's going to stay the same, of 91, okay? And now really we only have one more step. And here's what I want to remind you. I want to remind you that whenever you have a logarithm where the base is exactly the same as what's inside the logarithm, the argument, whenever the base of the logarithm is equal to the argument, it equals 1, okay? And you can go back to the lesson on properties of logarithm, or on introduction to logarithms to remember that if you need to. But the basic idea is logarithms are asking what is the exponent. 3 to what power equals 3? Well, 3 to the first power equals 3. Therefore, this logarithm equals 1. And therefore, what we now have is x times, this is 1, equals log base 3 of 91. Now, you don't really have to write out this step. This is assumed. What most people do when they're solving these is they just sort of cross out the logarithm because it's canceling, okay? When it becomes 1, and then 1 times x just equals x, so that means it basically goes away. So x times 1 is x, and our answer is log base 3 of 91. There we go. And that's our solution. That x. Now you may say, well, what is that? Can't we get a number for this? Yes. Log base 3 of 91 is a number. There are no variables in here, and therefore we could plug this into a calculator and get the number. I can tell you that it is greater than 4 and it is less than 5. Okay, it's just because I know a bit about logarithms, and hopefully you know well enough that log base 3 of 81 is 4, and then log base 3 of 243 is 5, and since 91 is between 81 and 243, log base 3 of 91 is greater than 4 and less than 5, okay? But in my class, now I don't know what your math instructor wants you to do, but in my class, to me, this is a solution, and therefore it can stay as is. It is an algebraic solution. Now, if you want an arithmetic solution, then you can go ahead and take this a little further, okay? And there's more things that you can do with this. If you wanted to level up to level 2 or level 3 with this, you could go back to the lesson on how to use the properties of logarithms to simplify, or not really simplify, more expand a logarithm, okay? But we're going to stop right here, okay? Let's do another example. Let's switch colors here. What if I asked you, hey, why don't you try this one? You pause the video. What's 8 to the x power is equal to 215, okay? Why don't you pause the video and you solve that using this exact same procedure. Okay, so we need a logarithm because we want to, basically the way I call it is we're trying to set the exponent free. We want to cancel the base of the exponent and we just want the exponent on one side of the equation. That's what we wound up with over here, is that the exponent wound up being by itself, okay? All right, so we're going to do log base 8 of 8 to the x power, whoops, there we go, equals log base 8 of 215. Over here, we're going to move the x in front of the logarithm. X times log base 8 of 8 equals log base 8 of 215. We're going to cancel log base 8 of 8, and we have x is equal to log base 8 of 215, and that is our answer. We are done. Now, I do want to show you something, what many people do when they start getting really, really good at solving exponential equations. They do shortcuts, which I like. I like shortcuts. And oftentimes what they'll do is when they get to this step, see how the x is right there? From here, they will do this. They will cross off the logarithm in 8, and then they'll just bring down the x. And in my class, you can do that. I'm okay with that, okay? And then, obviously, we bring down the log base 8 of 215. Saves us some ink, saves us some graphite from our pencil, saves us some space on the table, and we just turned a 4 or 5 step easy problem into a 3-step easy problem, okay? All right, why don't we try one now that includes the exponential base of e, because e is so important in the math world. Let's say we did one like this. Let's say we did e to the x power is equal to 150. Okay, so e to the x power is equal to 150. Now, to cancel e, remember, e is a mathematical constant that is approximately equal to 2.71828, blah, 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 blah. It goes like pi, it goes on, the decimals go on to eternity, but it's about 2.72. And so we need to cancel the e and set the exponent free. We're going to need a log base e. Now, don't use log base 2.72 because even though it's close, it's not precise. Log base 2.72 cannot cancel e. We need log base e. But remember, I don't know if you remember this, log base e is the same thing as natural log, okay? And so instead of, we don't write log base e in math, we just write ln, okay? So to cancel this e, we're going to need the natural log of e to the x power is equal to the natural log of 150. And then the x goes to the front of the natural logarithm. So we have x times the natural log of e equals the natural log of 150. And the natural log of e equals 1. Okay, this is one of the most infamous identities in all of mathematics. Okay, that the natural log of e is equal to 1. And so this is going to cancel. And all we have left is x is equal to the natural log of 150, okay? And that's our answer. We're done. You could easily key in natural log of 150 into any scientific or graphing calculator. You can even type it in on Google. ln parenthesis 150, close parenthesis, enter, and it'll give you the value of it, okay? All right. Or let's say, hey, Mr. Ryan, was I able to do that step where I just canceled out? Yeah, if you were right here, you did natural log e to the x, natural log of 150. At this point, you can just cancel out natural log in e, drop down the x, and x is equal to the natural log of 150, okay? All right, let's take it up a notch. I think we should go up now. We should complicate the exponent a little bit more now that we have the basic rule of how to cancel the base of an exponent with a logarithm. So let's try this guy. Let's try this. How about 2 to the power of 3x is equal to 85, okay? Just kind of making stuff up here. Now, do you see how the exponent is different? Instead of it being just 2 to the x, it's 2 to the power of 3x is equal to 85, okay? Now, we cannot cancel the base of 2 and the coefficient of x, 3, we cannot cancel both of them at the same time. It's going to take 2 separate steps to be able to cancel that, okay? So we want to set the whole exponent free. We want to set free the 3x. So eventually we're going to have down here 3x equals something, just like before we had x equals. So how are we going to cancel this base, exponential base of 2? We're going to use a logarithm. So we're going to do log base 2, because the exponential base is 2, of 2 to the power of 3x is equal to log base 2 of 85. And then we're going to cancel log base 2 of 2. Well, let's do it the long way just for a minute. We're going to move the 3x to the front of the logarithm. So we're going to have 3x times log base 2 of 2 is equal to log base 2 of 85. And now log base 2 of 2 equals 1, so that cancels. And now what we have is 3x is equal to log base 2 of 85. And now we know how to do this one. Back when we did linear equations a few lessons ago, we want to get the x by itself. So we want to cancel the multiplier of 3. And so we're going to divide by 3 on both sides. Whatever we do to one side, we have to do the exact same thing to the other side, okay? We're not dividing 85 by 3. We're dividing the entire logarithm by 3. It's going to cancel the 3, and we have x is equal to log base 2 of 85 divided by 3. Now, this can be represented in other ways, and maybe I'll do that in a different video where I do, like, advanced exponential equation, solving and stuff. But I don't want to confuse my students And so this is how I want you to represent the answer. We're gonna stop right there, and then you'll move on to the next question. You'll get full points for this one, and then move on to another one that you can get full points for. All right, let's try another one. But you know what? We're going to complicate the exponent a little bit more, and well, not complicate it. We're going to change it. Instead of 3x, let's say we do like x over 3, but let's do x over 4. What if we had e to the power of x over 4, and let's say that that was equal to 672, okay? And by the way, this number over here really doesn't matter. It can be any value, all right? I'm just making up numbers. So here, we know that we want to cancel an e, a base of e, so we need log base e, but we also know log base e is natural log. So we got to do natural log of e to the power of x over 4, make that a little larger, is equal to the natural log of 672. Now, the x over 4 can come to the front, and we'll have x over 4 times natural log of e is equal to the natural log of 672. Now, natural log of e equals 1, so that cancels, and so we have x over 4 is equal to the natural log of 672. And now we can cancel this over 4 here, okay? So x over 4, to cancel a divisor, in algebra, we know, so we got x to the first power over 4, and we learned in linear equations that we multiply by 4 on both sides. We're going to cancel the 4, and now we have x equals. Now, multipliers. We normally don't put them after the logarithm. We normally put them in front of the logarithm. So we're going to say 4 natural log of 672. And we're done. That's our final answer. Now, again, you could actually put the 4 inside the logarithm as an exponent on the 672, but we're not going to do that in my class. We're developing a skill, so let's leave this at the lower level for now. We're going to leave it as 4 natural log of 672, okay? All right, great. Let's try another example. Now, let's complicate this exponent. Instead of 3x, what if we had like 3x plus 5? 3x plus 5. Let's see what that would look like. Okay. All right. Now, and understand that these techniques that we used here on e could just as easily be used on. In fact, let's do an example before we complicate things. What if we had 9 to the power of x over 5? X over 5. And let's say that this was equal to 100, okay? Why don't you try this? Why don't you go ahead and pause the video and see if you can solve this on your own. All right, so now I'm going to try it. We want to cancel an exponential base of 9, so we're going to do log base 9 of 9 to the x over 5 power is equal to log base 9 of 100. Because remember, whatever we do to one side, we have to do the exact same thing to the other side. So log base 9 on the left, log base 9 on the right. Okay. We can cancel the log base 9 of 9. We can drop down the x over 5, and that's equal to log base 9 of 100. Multiply by 5 on both sides. Cancel the 5, and we have x is equal to 5 times. We're just going to put 5 and then log base 9 of 100. And that's it. That's our answer. We're done. I hope that's the answer that you got, okay? And if you didn't get that answer, then I think what you should do is maybe back up the video, go back to the beginning of this, and then try doing it again in a fresh spot on your note sheet or on a scratch piece of paper, okay? All right, so now let's make things a little more complicated. When I say complicated, it's not really more complicated. It's just an extra step, and it's a step you've done before in a different algebra problem on a different day, so it's really not that big of a deal. So let's say that we have 13 to the power of 21x minus 43 is equal to, 917, okay? All right, listen, these numbers, it doesn't matter what size the number is. Now, let me tell you what does matter. is that we're not going to do it on, we're not going to make this negative, okay? That's a new level of understanding, okay? So we're going to have our bases that we're going to deal with in this class are always going to be positive bases, okay? Also over here, our answers over here are also going to only be positive, okay? So, and I be positive that if you try to put a negative on there, then you're going to mess up the problem and you're not going to get it right. Having a negative over here is a completely new level of mathematical understanding. So we're not going to do that at all. We're going to have a positive over here as a base. We're going to have a positive over here, okay? All right, so we want to cancel a base of 13. So we're going to go log base 13 of 13 to the power of 21x minus 43 equals log base 13 of 917, okay? And then over here, we're going to cancel the log base 13 of 13, and we're going to bring this whole exponent down. We're going to bring down the whole thing. 21x minus 43 is equal to log base 13 of 917. And now what we have is a linear equation, something that's easy to solve. You might say, Mr. Ryan, that's not a linear equation. This right here is a logarithm. Yeah, I get that. But here's the thing. What you have to learn to see is this. If you have a logarithm with a number here and a number here, it's actually just a number. It's a constant, okay? Probably a decimal value, but it is a constant, okay? And so we're going to treat this like a linear equation. If I had 21x minus 43 is equal to, let's say, 5, the first thing I would do is I would add 43 to both sides. Add 43, cancel over here. 21x is equal to log base 13 of 917 plus 43. And so now all we have to deal with is this 21x. Now, you may be wondering, why did I put the plus 43 over here? Why didn't I put 43 plus over here? Okay, so here's the deal. Multipliers of a logarithm, we typically put them in front. So if we're multiplying by 5, we'll put 5 log base 13. But addition and subtraction typically goes on the right side of the logarithm. That's why I put plus 43 over here on the right, okay? And so now what we're going to do over here to solve for x is we're going to divide by 21, just like it's a linear equation, because it is. We're going to cancel the 21. Over here, we're going to divide by 21. Now note, we have to divide the whole thing by 21, okay? There are other ways you can do that. So you could divide this logarithm. Oh, no, you can't. I'm sorry, because of the plus. You can't do it that way. So you got to divide the whole thing by 21. Well, you could separate. I'm sorry. You could separate the fraction. You could do log base 13 of 917 over 21 plus 43 over 21. But for my students, just ignore everything I just said. We're just going to write it like this. The whole thing is going to be over 21. And so our final answer is x is equal to log base 13 of 917 plus 43 all over 21. And that's our answer. And you might say, that does not look like an answer, Mr. Ryan. Well, it is an answer, and I'll tell you why. Because everything in here, because all we see are numbers, because there's no variables here, this, were you to plug it into a calculator, would give you a constant number. It would give you a value, and that value would be the solution for x. If you then took that value and put it here and did 21 times that minus 43, and you raised 13 to that power, you would get 917. Okay. All right, let's try this is about as far as we're going to go, but let's just do one or two more examples so that you can develop your skill. Why don't you try this one? Why don't you try, I don't know, 37 to the power of 8x plus 5 is equal to 1200. 1200, okay? Why don't you pause the video and try that one on your own. All right, so we know that we want to cancel the exponential base of 37, so we're going to do log base 37 of 37 to the power of 8x plus 5 equals, and again, we need log base 37 of 1200, okay? There we go. And so over here on the left side, we're going to cancel the log base 37 of 37, and all we're going to have left is 8x plus 5 equals log base 37 of 1200. Okay? Now we're going to subtract 5 from both sides, and so we have 8x equals log base 37 of 1200 minus 5. Now, do you see this little 37 here? It's just an aside. This little 37, that's a little tiny 37 hanging out at the bottom of the log. Every once in a while, I'll see students that'll write this. Log 37, 1200. This is meaningless. Okay? This 37 needs to be a little tiny 37 hanging out at the bottom of the G. Okay? Be sure to do that. I don't know who your instructor is, but they might knock you for doing something wrong with the base of the logarithm. All right, so we got log base 37 to 1200 minus 5. Now all we got to do is divide by 8, divide the whole thing by 8, cancel, and we have x is equal to log base 37 of 1200 minus 5 divided by 8. Okay, and so. And there are lots of ways that you can manipulate the appearance of this logarithm because of the properties of logarithms, okay? But in my class, this is how we're going to write the answer, okay? All right, so I think, you know what, let's do at least one more. I think we should do one more example just so that you can, get, I'm going to actually throw in, there's actually one kind of appearance of a problem that I have not done yet, so let's try something different. Let's use this one. What if we had e to the power of 2x over 5 minus 1 equals, 57, okay? Why don't you try this one on your own? Now that you have abilities, this actually has one extra step that we haven't done yet, but I think that with your skill you might be able to do this, okay? Pause the video and try this. All right, so here's what we're going to do. We want to cancel the exponential base of e, so we need a natural log for that. So we're going to do natural log of e to the power of 2x over 5 minus 1 equals natural log of 57, okay? We're going to cancel the e and the natural log, so all we have now is 2x over 5 minus 1 equals the natural log of 57. Okay? And now we want to get rid of this 1 because we're solving for x, so we're going to add 1 to both sides over on the end, cancel, and we have 2x over 5 equals the natural log of 57 plus 1. All right. This is where it's going to get just a little tricky. Okay, not tricky, but just I haven't shown you this yet in these examples. We're going to cancel this denominator of 5. So we're going to multiply by 5 on both sides. But when we multiply by 5 on this side, we have to put parentheses around it because of the distributive property. Anytime you have an expression that has a plus or minus in it, if you want to multiply something by that whole expression, you have to put that whole expression inside of parentheses and then do the multiplication. Because this 5 is not only being multiplied by the natural log of 57, it's also being multiplied by the plus 1. And so now what we're going to have is we're going to have 2x equals, because we're canceling this 5, 2x equals 5 times the natural log of 57 plus 1, okay? And then, now, this you could, depending on your instructor, distribute the 5. Okay, so this could become 5 natural log of 57 plus 5 times 1 is 5 plus 5. So your instructor may want you to write it like this and not leave it on the outside, but I don't care one way or the other. For my class, you can do it either way. So now we're going to divide by 2, cancel, and we have x is equal to 5 times the natural log of 57 plus 1, close parenthesis, over 2. And this is a number, so that is the answer. Okay? All right, so that's it. That's about level 1, level 2, and level 3 for solving exponential equations. If you get really good at this, you can actually really learn a lot in mathematics and do a lot of really cool and crazy stuff. Okay? All right, so I hope this helps you a lot, and I hope you do great in your class.